Hello, all you processing users. This is John Park from the University of Oregon, and today I want to talk to you a bit about using tables as a way to bring in data, such as a data set that you have collected or found, and load that into processing and use it for visualization purposes. So I'm going to start from a blank canvas here. The very first thing you need to know about is a class within processing, I think processing 2 and 3 here, called table with a capital T. So like loading and making a P image type of thing, it's a very similar setup here. So I'm going to say table, and I'm just going to call my table table with a little t. You'll see that the orange one means that's a built-in class, and the little case t just is whatever name I wanted that to be. I could call that, user data or whatever. That's my own variable there, but I'll leave it as table. Down below, I'm going to put a void setup. I'm going to make the size of my sketch pretty good size. I'll say 1200, comma 700, and I'll do a void draw. Okay, now the very first thing is to actually load in a pre-existing table that I want to use. Now, when I'm talking about tables here, I think the easiest format to use here is a CSV file. A CSV stands for comma separated value file. This is not a proprietary file whatsoever. If you were to open up a CSV file in a text editor, it would just be values separated by commas. So in this case, if you open a CSV file in Excel or Google Spreadsheets, for example, it would look like an Excel spreadsheet with columns and rows. So this is just dummy data that I've collected. I'm going to pretend here that I have the names of 14 people and their ages, and like if I was observing their language and I said, well, how many positive words did they use versus how many negative words, and what home state were they from? Again, this is all made up data, but if this were real data, this is kind of a real world type of situation. So from Excel, I'm just going to, and if you create your own data, you might need to do this. I'm just going to make sure that I save this data as not an Excel file, but as a comma separated value. So there we go. And I'm going to make sure that this lives inside of my processing folder where I'm writing my code. So I'm going to call it tabledata.csv. That's fine. I'll click Save. Okay, and I'll just click Continue. Now that I have that thing called table data floating around, let me go ahead and just show you what I mean. Here we go. Table tutorial. Okay, so here's the CSV file that it spit out. If I look at this, just in a little quick preview, it looks like a grid, okay, of just columns and rows. But if I were to open that thing with, say, text edit or any kind of text editor, you can see that this is just, there's no formatting information here other than just commas. Each hard return that goes down is a new line or a new row in Excel, and then each new cell is separated by a comma. So it's a very open format. So if it's called tabledata.csv, I'm just going to copy that name. And now I'll go over into processing and say table equals load table, and then in parentheses I'm going to put in the name of my CSV file. So there it is, tabledata.csv. Now, one really important note here, if I leave that as is and I were to load that in, processing would think that this first row, which I've written in the labels for each of these columns, such as name, age, etc., it would think that that's data, and that this element here, age, is sort of like the same type of thing, like each of these cells below it. But we all know that that's not the case, right? This is a label. So if I want to have the program ignore this first row, assuming that those are all labels, in processing, after I end my name for the CSV file, and outside of the quote mark, I would put comma, and then in quote, header. Okay, now that should get rid of that first row in terms of it loading that stuff in. So let's first of all run this and see, make sure it doesn't have any errors. I'm not going to see anything, but okay, no errors. That's a good sign. And so now let's say, well, what can we really do with this? So let's begin here. Okay, well, certainly one thing that we can do is talk about some built-in terms that we have accessible to us. So these are all sort of built-in features of this table class. So I could say, let me do a print line. Remember, print line will let us spit out a small little message in the little console window down here. So if I want to do a print line, and I could say print line table.getRowCount and open and close parentheses. That term will tell us how many individual rows we have in our data. So let me just close off the parentheses for the print line and a semicolon. Now when I run that, because that's inside of void setup, that print line should run once and spit out a little message down here. So let's go ahead and do that. Okay, it says, hey, 14 rows. Okay, let me change that from get row count to get column count. This is, hey, you've got 5 columns. Okay, so let's look back at the data. Let's see, 1, 2, 3, 4, 5 columns. That sounds right. I can see there are 15 different rows here, but remember, we told processing to ignore this first row, this header row, so therefore it does make sense that we have 14 rows of data. So that's really good. That's working out well. Now, that's how we can kind of get the total count of rows and columns, by either saying table.getRowCount and table.getColumnCount. And just to make notes here, I'll put that down there, and I'll put another one down here. And instead of column, I'll say row. So this is just kind of notes to self on how to access data. Now, next up, okay, so how do we access individual data points, right? It's going to be very common that we need to know, for example, how old James is here through code. And so we have another very useful set of features, which is to find out how to pinpoint or target specific data. So what that's called is, in the same print line here, I'm going to say keep this as table, and I'm going to use get, but instead of get column count or row count, I could either ask it to get a string, a float, or an int. And this all depends on what type of information it is. If it's text that we're talking about, such as the name of someone, it would be getString. So I'm going to start with getString. Now when we say table.getString, it's going to want to know 2 numbers inside of these parentheses that follow it. It's going to want to say which row are you talking about and which column. So when I talk about which row, let me go back to the data and say this is going to be saying which row. It'll think this is 0. Okay, it says 2 in Excel, but you can ignore that. Remember, we're ignoring the first row, and this is like working an array where a numbered list starts with 0. So if I want to have it spit out James, I would say the 0th row and the 0th column. So let's see if that works. 0, 0. And I'll run that. And it says, hey, James. Excellent. Now, if I want to go down to a different row, this first number would change down. So let's say the 4th person. Even though it says number 3, it's the 4th, because remember this list starts with 0. So I'll run that and say, oh, Terry is the 4th person, etc. So there we go. That's getString. Now, what I'm also going to do is copy this, paste it below, and say that's for text-based data. The other common one would be getFloat. So all of these ages are actually set as integers, and you can treat an integer like a float. Remember, an integer is a whole number, and a float is a number that's a mixed number that could be a decimal based, such as 34.5 instead of 34. But it's okay to kind of pretend like these are floats. It'll probably say 34.0 instead of 34. So if I want to know the age of someone here, instead of getString, I would say table.getFloat. I could find out the age of this 4th person, and I would do that by now saying, well, I don't want it to refer to the 0th column, because that's the names. I want to find the ages. That would be the first column. So instead of getFloat 3, row 3, column 0, I'm going to get row 3, column 1. And let's run that. And so now it's going to say Terry is 21.0 years old. And again, let's look at why it's doing that. Well, here it is, the 3rd person in this list, or the 4th person, I'm sorry, Terry, 21.0 years old. Okay, so really knowing these four things, table.getString, table.getFloat, table.getColumnCount, table.getRowCount, honestly, that'll get you super far. So let's start with using this in the actual visual sketch. Inside the void draw, I'm going to set this background to be white. I'm going to set the fill to be black. And let's start just by having this thing print out all the names of the people in this list. Okay, so I'm going to print that out just in terms of text being displayed on screen. I'll write the word text, and I'm now that I think about it, well, gosh, if I have 11 or 14 names, or if you have a real data set that has 1,400 points of data, you're not going to want to write something out 1,400 times. That would be terrible. Instead, we might as well make a loop, right? A loop that will go through every single X number of items of data that you have, and then just extract the piece that you need and do something with it. So guess what? Time for a for loop. And if you don't know what a for loop is, I would definitely pause this tutorial right now and go watch either my or someone else's for loop tutorials to talk about what the heck this thing is. But it's very powerful. So we're going to use the word for, and we're going to open a parentheses and say int, and it doesn't matter what we call this thing. I'm going to say int d equals 0. D is less than, and normally when you say D is less than, you'd put a number like D is less than 5 or 500, etc. Well, here we have a data set, and we remember that this thing had 14 rows when we said get row count, but honestly, that number might change later. If you add more data to this data set, for example, it might shift around. So if you want to be very dynamic about this and smart, we could say D is less than table.getRowCount. And then if the number of rows change, it will dynamically read that change and kind of intelligently expand your program to match. So semicolon there, D++. I'm going to close out the parentheses, open a curly bracket, and then kind of below this little text snippet that I started, I'm going to drop down and close that curly bracket. Okay, so now that I have these three lines here, the text is inside of this for loop. Now I can remember that really this number here is 14. Table.getRowCount, we remember that was 14 before. So this loop is going to run 14 times, or between 0 and 13. So if I want to spit out the names of this text, I could say the actual string is going to be table.getString, row number what? Now, before I put in the number 0 and it was the first row and 1 was the second row, etc. So now if I'm going to go through all of 0 through 13 in this for loop, I can just refer to this letter D because D starts at 0 and goes to 1 and 2 and 3 all the way to 13. So what if I just say get string D, since we know that's a number that's growing, comma, which column? Well, we're talking about column number 0 because column number 0 is the one that has all the names in it. Okay, great. So just by doing that, this here should be a string, and that should be each string, each name in that column of names. Okay, now I'm going to put a comma here, and I'm going to say, well, where is this going to get drawn? Well, I'll just say 100 pixels over on the x-axis. And remember, this third parameter is always going to be the y position. So I'm going to say 25 down from the top plus, so this is kind of like a margin on the top, plus D, that's whichever name we're at, times 25 pixels. And again, this doesn't have to be 25, this could be 30. This is essentially saying the line spacing between one piece of text and the next one down. Okay, and I'm going to make sure there's a semicolon at the end of that. So let me go ahead and run this and see what it looks like. Okay, there we go. James, Sarah, Frida, Terry. It's going through all of the entire list. In case this math is a little bit weird to you at the end, the 100 here is going to be the X position, or 100 pixels over from this left edge. The 25 here is going to be 25 pixels from the top of this edge down to the bottom of James, and then the space in between from the bottom of James and the bottom to Sarah, that's where this 30 comes from. So if I were to change that to 50, for example, the line spacing between all these lines would be a lot wider or greater. Okay, so there we go. Okay, good. So now we're kind of onto something with accessing what we need from our CSV file. Now that would just be something like labels. Let's say we want to draw ellipses or circles. We'll call them circles. And the older the person is, the bigger the circle. All right, that kind of makes sense. So let's start by making an ellipse. Whenever you do an ellipse, it wants the X position and the Y position. So we know that all the text is drawing at 100 pixels over from the left margin, and then the width of whatever that name is, right? So if it's a really long name, it'll be even wider. So to be safe here, let me draw this at, let's say 180 pixels over will be the starting point of the ellipse, and we could change that later if it's not right. Now the second thing we want to know is the Y position of the ellipse. Well, we know the Y position of our text is right here, right? 25 plus D times 50. So I'm going to copy that Y position so that my ellipse will kind of line up with the text, right? And so for now, I'm going to kind of do that, and I'll just put in two dummy values for the width and height. So I'm going to say 15, 15. That's the part we're going to be changing later to be affected by age. But I think it's smart now to just leave these all at 15 so that we can see if this does what we think it will. Okay, and let me run that and see. These should be black ellipses or circles. Okay, so there we have it. Now, one little issue comes up, which is we can see that when text draws by default, its position lines up with the bottom left side of the text box for James and Sarah and Frida, etc. But when we draw an ellipse and we tell it to do it from a certain place, it's drawing from the center. So we could either center align the text, or we could align the ellipse to go from the bottom or the top instead of the center. Now I think aligning the text makes a lot more sense. So in the void setup, if you want to change text alignment, you can say text align. Okay, all one word, it'll turn blue if you spell it right. Text align, and it first wants to know the horizontal alignment and then the vertical alignment. So I could say left justified, comma, center justified vertically. Okay, horizontal alignment, vertical alignment. And now let me run that and see how it looks. A little bit better. You can see the middle of James looks like it's matching up with the middle of the ellipse, etc. Better and better. Okay. So now that we know that much works, now let's look at having the size of the ellipse be affected by the data. Okay, if I'm going to use the person's age, we're really talking about this second column of data, and we know that the range, I'm pretending like this is about college campus ages, so a lot of 18 to 22s with the occasional, let's say, grad student or faculty member or staff person that might go into your 30s or 40s, etc. But really with this data, my range is anywhere between 18 and 34 is what I chose to do this dummy data as. So here we go. If we want the size to be affected, we're really talking about these two numbers. In the ellipse, that's the third and fourth parameter. The width would be 15 here. The height is set to 15. So instead of those two numbers, let's say table.get float. Remember, we did this before. Same thing like we did up here. We're going to do the letter D first, so we'll go through all the values in each row, comma, and then which column? Well, remember, column number 1 is the ages. Okay, column number 1 is the ages. So that right there should be saying, go through all of these. Okay. Now what I'm going to do is grab that value and replace 15 so that it has the same width as it does the height. Okay, and let me go ahead and run that. There we go. Now we can see James is older than Tim and Cora, for example. Now, depending on the type of your data or the range, these numbers may be way too big, they may be way too small. how could you really deal with that? Well, if they're too small, what we could do is just say, well, outside of the parentheses, since we know this is the number right here, outside of the parentheses, why don't we just multiply that by a number? So that number will be 10 for now. And I'm going to, again, make sure I'm outside of the parentheses for the get floats and say asterisk 10. And now we'll run that. And if all is well in the world, whoa, 10 was a little bit big given this scenario. You can see these are huge. So what I'm going to do is instead of 10, I'll change these to 2's. And another thing I can do is for the color of the text, I'm going to set above the text, I'm going to set the color to be black. And then below the text, I'm going to set the color or the fill for these ellipses to be, an actual color instead of being black. And so there's the red, green, and blue value. And I'm going to add a fourth value. And remember, the fourth value in any color is going to be its opacity, or how transparent it is. So I'm just going to set this to 50, so that even if the ellipses overlap, I will see color. Okay, so for example here, where James overlaps with Sarah. All right, very good. Now, this will allow us to see some differences in age represented as size. A quick little note for people who are concerned about the accuracy of displaying of data, and I think in a lot of ways all of us should be, but perhaps this isn't, for a lot of you who are learning how to code, this might not be at the top of the list. You might just want to see this thing work initially. But if you think about what's happening here, we are taking a linear number, like essentially like a one-dimensional number, such as the age of someone, and we're having that represented in area, which is spatial. It's two-dimensional in this way. All of this is to say is that very quickly we can get an inaccurate picture of one age relative to another when we use area. If I were to say that a 10-year-old versus a 30-year-old, if those were represented as lines and set them next to each other, that would be just fine. We could see one line is 3 times longer than the other line. But if we take the area of one thing and take its radius or its diameter and compare that to the area of another thing that has a diameter that's 3 times larger, the total area being shown will actually be 9 times larger just by how area works. So if you're kind of concerned about accuracy here, what you'd want to do is take the square root of your value, and I'd say SQRT. Do this. SQRT, that's the square root of whatever value you have. And you only want to do this if you're doing something with area, by the way. That would be the ellipse or a rectangle, but not lines. If we take the square root of those values and then we multiply them by a factor, the shape is going to look much smaller, but it will better or more accurately represent these things. So here they are really small. Now that we took the square root of them, multiplying by 2 doesn't really do much. If we multiply them by 12 and now run this, they should be quite a bit bigger. Okay, and this is actually much more accurate than before. It doesn't look as glorious, like the range, the difference between James and Sarah, or Cora and Michael, for example, looks very subtle between these two, but that in terms of real representative area, taking the square root is going to give you a much more accurate result. So something to really think about in terms of accuracy. But anyways, that is one of many ways in which we can have the color being affected by something else. Now, I want to go into just one last thing here, which is, if you were going to talk about how many positive words versus negative words, you could tie in other visuals to this. They could be lines or squares or whatever really you want. But let me look at this last column here, which is called home state. Let's say that I want to change the fill color of each one of these ellipses based on what home state we're talking about. Okay, now that's kind of an odd question to do. I'm going to simplify these. I didn't put too many states in here, just to keep our life simple. But what I want to do is up here, right before I draw the ellipse, I want to put an if statement here. Okay, and essentially what I want to say is, if the home state is Oregon, do one thing. If it's California, do another. If it's New York, do a different thing. And that thing that's going to change is going to be the fill color. So what I want to say is if table.getString, because the values in the home state columns are all letters, therefore we're talking about strings, getString, row number D, column number 0, 1, 2, 3, 4, dot 4. Okay, so that's the string now. And what I want to do is I want to say, well, if that string is the same as the letters O and R, capital O R, then do something. Okay. Now, if we're comparing numbers in an if statement, you would put two equal signs. You'd say if age equals 34, then do something else. But since we're talking about seeing if one piece of text is the equivalent or the same as a different piece of text, we instead want to say dot equals. Okay, dot equals, because when we take one string and say if it's equal to a different string. So this is the string that's in yellow there, dot equals, and I'm going to put OR for Oregon in quote marks. Okay, so there is a condition. This is going to be either true or false, the stuff that's in yellow. Is it equal to Oregon or not? If it's California, this will be false. So I'm going to close off the if statement. I'm going to open a curly bracket. And below the fill color, I'm going to close the curly bracket. Okay, so this is now one complete if statement. If it's Oregon, then do this color. I could then just say else and say, well, if it's not Oregon, let's make these a different color. So I'm just going to change this fill, and I'll change these numbers around a little bit. There we go. And let's see if this works. Okay, here we go. So now what we're doing is we're saying the green ones are Oregon, James, Sarah, Cora, Bella, and Monique. It did recognize that in that column of their home state, they were Oregon. And so if I go back here and let's just see if this is in fact true. Home state, James, Sarah, who else did I say? Cora, this is looking right. Bella, and so on. All right, now you can kind of continue that out with some other if statements. You could say else if, and open a parentheses, and just copy all this stuff again. And instead of looking for Oregon, let's say, well, if you're California, then we want to do something else. What will that other color be? Well, I'm going to take this fill color and just change it to a different fill color. And again, I'm just making up these values, but we'll make this one a little bit darker, maybe more blue. Okay, so now Oregon's are greens, California's are blues, everything else is that default orange color. But just so you know, that's one way to kind of check for a condition and do something else with it based on what that condition is. All the thing that's being changed here would be either one color or another color or another color. After all that kind of if stuff is done, then just draw the normal ellipse. Okay, and the only thing that's going to be changed now will be its color from those if statements, and its size will be changed based on, in this case, the age of these people. All right, so hopefully that gets you started with doing some kind of data visualization in processing. Of course, there are many different visualization techniques and different ways to display the data, but this is just, hey, day one, how do we get access to a CSV file? And by the way, there are enormous quantities of really great CSV files available on the internet. Starting at data.gov as a website is a really good beginning place. Thank you all. I hope this was of use, and yeah, we'll see you next time. Bye-bye.